Hey everyone, today we will be talking about predictive maintenance, also known as predictive analysis, a data driven approach that transforming the way industries maintain and operate their equipment. Instead of waiting for machine to fail, predictive maintenance help us anticipate the problem before they happen, saving both time and resource. So let's start by understanding why this topic is so relevant today. To begin with, what really motivated us to choose this topic? Our motivation came from a shared interest in how data and the Internet of Things are reshaping logistics and manufacturing. In industries like transportation and supply chain, even small breakdown can lead to big delay and losses. Predictive maintenance addresses that by reducing unplanned downtime, improving safety, and boosting efficiency. As a student of integrated transport and smart logistics, we wanted to explore how this technology can optimize real-world operation and make system more reliable. Now that you know what inspired us, let's take a quick look at how we structured our presentation. Here is our roadmap for today's presentation. We will begin with our motivation, which we just covered, and then move on to understanding the technology behind predictive maintenance. Next, we will look at its technology readiness level, discuss current challenges, and highlight both business and societal value. After that, we will explore the real-world demonstration and case studies from major companies to see how predictive maintenance work in practices. Finally, we will conclude with takeaways and then open floor for a short question and answer section where we would love to hear your thoughts and questions. So with that overview in mind, let's dive into the core concept, what predictive maintenance actually is and how it works.
So let's start with the essence of what predictive maintenance actually is. Predictive maintenance uses sensors, data analytics, and machine learning to forecast when a machine might fail. Instead of waiting for something to break down or sticking to a rigid maintenance schedule, companies can now service equipment just at the right time. Not too early, not too late. And it's all about smart timing and efficiency anyways nowadays. Now that we know what predictive maintenance is, let's look at how it actually works. The process is completely data-driven. Sensors continuously collect information from equipment, and this data is analyzed to detect patterns or anomalies. When the system predicts that a component might fail, maintenance teams gets an alert to step in, and thereby they try and prevent unexpected downtime and costly breakdowns before they happen. So where does all this data come from? It starts right at the source, obviously the machines themselves. Data collection is really the foundation of predictive maintenance. Sensors capture key parameters like vibration, temperature, force, noise levels, and electric current. Each of these metrics tells a story about the machine's health. Let's consider this instance. A machine starts vibrating unusually, so it could be an early sign of bearing wear or misalignment, and this could be understood if we have predictive maintenance technology installed in our warehouse. So once the data is captured, the next question is, how do we make sense of it? The collected data is sent either to a cloud device or an edge device using Internet of Things, and from there AI and machine learning algorithms get to work analyzing the data to identify abnormal behaviors and patterns or early warning signs. And the best part, the system learns continuously. Over time, it becomes more accurate at finding potential failures before they even happen. So what happens when the system actually detects something unusual? When potential issues are found, predictive models estimate when a failure might happen. And at that point, automated alerts are sent to maintenance teams. This proactive approach keeps operations running smoothly, and it boosts equipment lifetime, and it ensures safety, all while reducing unnecessary maintenance cost. Behind the scenes, several advanced technologies work together to make this possible. The core technologies enabling predictive maintenance include the Internet of Things, which provides real-time data, machine learning and AI, which recognize patterns and predict failures, cloud computing and big data analytics, which processes huge amounts of data, and digital twins, which are in fact virtual replicas that stimulate how equipment behaves. When these technologies come together, predictive maintenance becomes scalable across various industries. And speaking of industries, this technology is not limited to just factories. Predictive maintenance is used across manufacturing, aviation, energy, transportation, and logistics, and so on and so forth. To give you an example, let's consider Air Baltic, an airline, right? So, such airlines use predictive maintenance to monitor their fleet's engine health, and this is done so as to avoid in-flight failures, obviously. While logistic companies like DHL or Amazon rely on such technology to manage their fleets and to keep their warehouse machinery running efficiently for longer period. So predictive maintenance is, to summarize, it's truly transforming how industries maintain and operate their assets.
Let's begin by looking at where predictive maintenance stands in terms of technological maturity. Right now, it's at technology readiness level 8 to 9, which means it's not just experimental anymore. It's fully operational and validated in real-world conditions. In fact, according to PwC, nearly half of all industrial enterprises have already implemented or are in the process of scaling predictive maintenance solutions. So, we are clearly looking at a technology that's proven and rapidly expanding. Now that we know its readiness level, let's see what evidence supports this maturity. When we look across industries, the evidence is clear. Sectors like aviation, rail, and manufacturing already rely heavily on predictive maintenance. Tech leaders such as IBM, GE, Siemens, and SAP offer full-fledged commercial PDM platforms that combine IoT, AI, and advanced analytics. These systems are capable of near-automated diagnostics, allowing companies to predict equipment failures with remarkable accuracy, sometimes even weeks in advance. So, how does this look when put into action in the real world? Let's take a closer look. In real-world applications, companies like Deutsche Bahn, Caterpillar, IBM, GE, and Siemens use predictive maintenance for their turbines, engines, and heavy machinery. In the logistics sector, DHL and UPS apply these systems to monitor vehicle fleets and warehouse equipment. By doing so, they have managed to cut unplanned downtime by more than 20%, improving both reliability and operational efficiency. In our opinion, predictive maintenance has now reached a stable commercial phase. Large organizations have fully embraced it, but small and medium enterprises still face a few obstacles, mainly high setup costs, limited technical knowledge, and integration complexity. However, with rapid advances in AI, IoT, and cloud computing, these barriers are starting to fall. Looking ahead, we believe predictive maintenance will become a global industry standard within the next 3 to 5 years. So, what lies beyond that? Let's explore what the future might look like. The next big step is the shift toward autonomous and self-sustaining maintenance systems. We are moving into an era where AI-powered decision-making and digital twin technology will work hand in hand, creating real-time simulations that can predict, diagnose, and even correct issues automatically. In essence, machines will soon be able to maintain themselves, making maintenance almost invisible yet more reliable than ever. Of course, no technology is perfect. Despite all its benefits, predictive maintenance still faces a few hurdles. The most common issues include high initial investment costs, complex implementation, and data quality changes. There are also growing concerns around cybersecurity, as connected systems are vulnerable to digital threats, and for many companies, The return on investment isn't always immediate, which can make adoption difficult. Overcoming these challenges will require not only technical innovation but also strong management support and workforce training.
Now that we have covered both the strengths and the challenges, let's look at how these values translate into real business and societal benefits. From a business point of view, predictive maintenance creates real measurable impact. Companies that adopt it report up to 40% cost reduction, 45% less downtime, and 25% longer equipment lifespan. These aren't just numbers, they represent smoother operations, fewer disruptions, and higher productivity. In short, predictive maintenance doesn't just fix problems, it strengthens efficiency, safety, and overall performance. But the value of this technology doesn't stop at business metrics. Let's see what it means for society as a whole. Beyond business benefits, predictive maintenance also contributes to sustainability and public safety. By preventing failures, it reduces unnecessary energy consumption and material waste, which means fewer spare parts produced, less downtime, and a smaller carbon footprint.
And now that we have discussed everything, almost everything about predictive maintenance, let's see how it actually works in action. Here is a short demonstration using IBM's Maximo Predictive Maintenance platform, which is in fact one of the leading solutions in this field.
Let's say Alice is an operations analyst with your company, and she's using IBM Maximo to remotely monitor all of her company's assets in a single view. The AI alerts her that there's an issue that warrants immediate action. With a click, she can see she can drill down to investigate. The issue requires a physical inspection, so she creates a service request. And since everyone on Alice's team has access to IBM Maximo, which also integrates all data and workflows together, the second Alice completes and submits her request, Franklin, a maintenance supervisor, receives a work order. Franklin evaluates assets across multiple facilities from a central location. He reviews the work order and attaches the appropriate job plan from Maximo's rich industry-specific workflows. Then Sarah, a technician chosen for her expertise in this area, receives notification of the work order on her mobile device. Sarah pulls up the asset's history, job plan, and documentation, and she gets to work. The fix is one she hasn't done before, but Sarah has two options to assist her in completing the task. She can use prescriptive AI assistance that analyzes thousands of documents to provide the fix with the highest probability to succeed. Or she can contact an expert remotely for support. Here, she's using the camera on her tablet to show her colleague the asset in need of repair. She also uses the camera on her tablet to receive visualized step-by-step instructions delivered in real time. Once she makes the necessary repair, the actions taken are logged in your maintenance history. The new data then updates the asset history, and a recording is stored and available for the next person who has this issue, creating a continuous learning loop, ensuring you have better AI-driven insights into all facets of your operations, including the health of your assets, better predict failures, utilize AI-powered vision models, and optimize service scheduling, as well as worker safety, all on a single platform with multi-cloud deployment options. Host IBM Maximo in the environment of your choice, or let IBM manage it for you. Transform your business with IBM Maximo Application Suite, the complete asset management package to keep your business thriving for years to come.
Now let's look at how one major organization put these ideas into action, starting with Deutsche Bahn, Germany's national railway company. Deutsche Bahn operates one of the largest train fleets in Europe, where even a short delay can impact millions of passengers. Traditionally, maintenance tasks like manually inspecting train roofs took hours and often led to downtime. To overcome this, Deutsche Bahn introduced predictive and condition-based maintenance using IoT sensors, artificial intelligence, and cloud analytics. Every day, around 50 gigabytes of data are collected from trains, tracking vibrations, temperature, and braking performance. AI systems now automatically analyze this data, spotting early signs of wheel wear, brake issues, and track faults before they cause disruptions. So far, over 28,000 track turnouts have been fitted with sensors, leading to the early detection of more than 3,600 potential failures. Thanks to these systems, Deutsche Bahn has significantly improved punctuality and fleet reliability. The company now generates more than 150 million AI-based forecasts per day, keeping trains running smoothly and passengers on time. This case perfectly shows how predictive maintenance is turning traditional railway operations into smart data-driven systems, proactive rather than reactive. And this isn't just happening in rail. Similar digital transformations are reshaping logistics, aviation, and manufacturing industries worldwide.
Now, let's turn our attention to DHL, one of the biggest names in global logistics, moving millions of parcels across the world every single day. Imagine the scale. In their massive sorting centers, even a few minutes of equipment failure can cause serious backlogs. That's where the predictive maintenance comes into play, and DHL decided to take it into the next level. To tackle these challenges, DHL introduced an IoT based predictive maintenance system across their facilities. This system continuously monitors conveyor belts and sorting machines using vibration, sound, and temperature sensors. They even used high definition and thermal cameras to detect the smallest irregularities before they become rare problems. So instead of waiting for a machine to fail, DHL system listens, observes, and learns from the data. Now, let's look at how this worked in action and some of their key sites. In their Munich Airport Gateway pilot project, the system detected a critical vibration issue before the facility even went live. That early warning prevented what could have been a costly breakdown. Similarly, at the Dortmund Service Center, the sensors identified just a 2 mm misalignment on a sorter circuit, something tiny, but it could have caused serious wear and tear if left unnoticed. They fixed it early and avoided a major downtime. So, what kind of results did all this bring to DHL's operations? The outcomes were impressive. DHL managed to shift from scheduled maintenance, where the machines are serviced on a fixed timeline, to true condition based maintenance, where the machines themselves indicate when they actually need attention. This shift led up to 24% lower maintenance cost and around 35% less downtime across their logistics hubs. In other words, smarter maintenance translated directly into smoother operations and happier customers. Let's wrap up with what this means more broadly for logistics and technology. To summarize, predictive maintenance combines IoT, AI, and data analytics to see problems before they happen. It's already at a high level of maturity, what's known as the technology readiness level 8 to 9, meaning it's being widely adopted across industries. Of course, challenges like high setup cost, data integration, and sensor accuracy still exist. But the direction is clear. We are moving steadily toward autonomous maintenance, where the system self-monitor and even self-correct. Ultimately, the predictive maintenance isn't just about fixing machines. It's about building a safer, more reliable, and more sustainable logistics environment.
So here are some of the references we made during our research into the topic. If you are really into predictive maintenance, or if you really want to know more about this topic, you can actually start by reading the article published by IBM in the year 2021. Or if you want to know more about the recent developments in this topic, you could read the article published by Fix Software in the year 2024. Fine, so that's it from us now. We would like to thank you for being so patient and careful throughout the session. Now, if you have something that confuses your mind, you can ask us now. The floor is open for discussions.